Right, next one. So, figure 10 shows a girl doing an experiment to determine her power output by running to the top of the stairs. So remember, power is how quickly you do work. So in this case, the work is running up the stairs. Okay? And the quicker you run up the stairs, the more powerful you are. Okay? Also has to do with the amount of mass that you have, because obviously if you've got more mass, you do more work. Okay? As always, I would always be the most powerful, so I would go up the stairs quicker than anyone else. So the mass of the girl was 60 kilograms. Now remember, kilograms gets kept as kilograms. That's just fine. That's one that you just have to remember. The height of the stairs was 175 centimeters. So centimeters is a pain in the neck because you can't use this card to work it out. You just need to remember what centimeters is. Okay, so centimeters is just dividing by 100, because you remember centi is for century. So we do 175 divided by 100. That gives us 1.75 meters, and that gets us there. And that makes sense. That would be about 1.75 meters. Okay, and then the girl ran to the top of the stairs in 1.4 seconds. So that seconds is fine, and gravitational field strength is 9.8, so that is fine as well. So all we need to do is calculate the power of the girl. Okay, use the physics equation sheet. So this is nothing to do with electricity. Okay, so we've got absolutely nothing to do with electricity. So we won't have anything to do with current or voltage or anything like that. So we don't want to have any power in that respect. So here we've got current. We definitely don't want that one because that's to do with electricity. That's to do with electricity because that's current. Okay, and I don't think we've got any other powers that are to do with that. Okay, so we don't want the electricity ones. This one's the best one to use because it's all about energy being transferred as she moves up the stairs. So if we use P equals E divided by T, power equals energy divided by time. Okay, so we do C, F, I, F, A. Now we've already done our converting, but I'll put that there anyway. 175 divided by 100 gives us 1.75 meters. Now our equation, if we remember, okay, was power, that's what we want, equals energy divided by time. Right, so we know we've got the time, so what we can do is insert the numbers. Power equals energy, which we don't know, divided by time, which we do know, of 1.4 seconds. I reckon I would do that in probably 0.2 seconds, ultimately resulting in more power. But anyway, we need to now work out energy. So we need to use another equation like we have been. C phi for, like that. Now we don't need to convert for this one. We do need to work out something that's got to do with energy. Now there's loads of things to do with energy, but the key here is she's going up, she's gaining height, and we know the type of energy that's gained when we gain height is gravitational potential energy. Okay. Also, we've got gravitational field strength here, so we're almost certain, and we've got height. So whenever we've got height and we've got gravitational field strength, we're definitely going to have to use the gravitational potential energy equation, which is just here, third one down. Gravitational potential energy equals mass times gravitational field strength times height. Now, it doesn't matter what kind of energy is energy. Okay, so we're just trying to find energy for this equation there, and it doesn't matter that it's gravitational potential energy. It's, as I said, just energy. So there's our equation. EP equals mass times gravitational field strength times height. So EP equals m times gravity times height. Now we put our numbers in. So EP equals mass, okay, of 60 kilograms times the gravitational field strength of 9.8 times by the height we already know of 1.75 meters. Okay, now if we put that into our calculator, we've got 60 times by 9.8 times by 1.75. That gives us, we don't need to rearrange, that gives an answer of 1029 joules. Okay, so we know that it's actually 1029 divided by our time of 1.4 seconds. Okay, I think I wrote 1.45 by accident there. Please excuse me for that. It's 1.4 seconds, or 1.40 seconds. So then we do 1029, well, fraction button, remember. So fraction button, 1029 divided by 1.4, that gives us 735 watts. Okay, and that's our answer, 735 watts.